All right, so we're doing weighted averages, and what we're going to do is magnesium occurs naturally in three different isotopes. One is magnesium 24, which is actually has an atomic mass unit of 23.985, but we round that off to 24. And it has an abundance of 78.99%. Magnesium 25, which is actually 24.986 atomic mass units, but we round it up to 25, has an abundance of 10%. And then the last bit, magnesium 26, which is actually measured at 25.983 atomic mass units, has an abundance of 11.01%. Determine the average atomic mass of magnesium. So when I'm teaching weighted averages, I actually like thinking about it in terms of grade point averages. And most people taking chemistry are juniors, and so they're kind of worried about their grade point average. And so let's kind of come up with an example to show you before, so that I can kind of show you where this stuff comes from. Because my biggest pet peeve that I have is I'm not a big fan of pulling equations out of thin air, but rather you understanding where they come from. So let's say that of the 4 years of high school, your freshman, junior, senior, or I'm sorry, freshman, sophomore, junior, and then senior year. So this is sophomore and this is senior year. You ended up getting for your grades a C average, so C and a C and a C. And at this point, you end up getting a C average for your freshman year, your junior, sophomore year, and then your junior year. And so you're like, okay, my grade point average is 2.0. And then you say, well, I really want to get a 3.0 grade point average for my college entrance or whatever. So what I'm going to do is I'm really going to work really hard in my senior year, and I'm going to get a 4.0 grade point average. And if I take the average of 2.0 and 4.0, and we know how to take an average, we add the two together, and then we say we divide it by the number that we added. So in this case, we had divided by 2. Let's see, 2 plus 4 is 6, and so you divide that by 2, and you end up getting 3.0, and you're like, sweet! Even though I got 3 years worth of 2.0, I can get my 4.0 on my senior year, and I have a 3.0, and I'm stoked. And I hate to tell you, but that's not how that works. You see, this 2.0 is, I guess, in a way, heavier or more important than this 4.0. And what I mean by more important is it's actually a worse GPA. But the thing is, it represents 3 years worth of your schooling, whereas that 4.0 only represents 1 year worth of your schooling. So what we really need to do to calculate out your GPA that you would get is we need to weight these things, not weight W-A-I-T, but weight as in W-E-I-G-H-T. And the way I'm going to do that is I'm going to say, all right, well, this 2.0 represented 3 years. So I'm going to multiply that 2 times 3. And then I'm going to add to that the 4.0, which represents 1 year worth of the stuff. And I'm going to divide that whole thing by the number 4. How come the number 4? Well, because it represents 4 years total. See, I'm not just adding 2 numbers. I'm actually adding 4 numbers because I'm adding 3 2s and the 1 4.0. And so then when you calculate out that, and I didn't pull up my calculator beforehand, so I'll do that now. Let's see. Well, I guess I could do it here. 2 times 3 is 6, plus 4 is 10. So really you'll have a 10 over 4 as your GPA, which comes out to be 10 divided by 4, 2.5. So I hate to say it sadly, but your grade point average is a 2.5 GPA, not a 3.0 like you would have wanted. So I guess another way to kind of play with this thing mathematically is to say, well, this divide by 4, I'm dividing both. So what I'm going to do is I'm going to make this a 2.0 times 3 divided by 4. And over here I have a 4.0 times 1 divided by 4, which kind of makes sense because 3/4 is really 75%, right? And I wrote it as a decimal, but you know, I could write it as 75 with a percent sign. And then over here I have 4.0, which is only 25%, because that's what 1/4 is. And that makes sense, because that 2.0 is 75% of your high school, is representing 75% of your high school experience, because you got a 2.0 on your freshman, sophomore, and junior year. Whereas that 4.0 only represented 25% of your high school experience, because you got a 4.0 only once out of the 4 different years. And if you calculate this out, you would end up getting the same number as 2.5. Now, this formula right here, which I explained to you, it really comes from this formula right here. It's not really that mathematical. It's not mathematically different at all. Is how we're going to use, what we're going to use to calculate out the average atomic mass of magnesium. So here's how I'm going to do it. I'm going to say, well, I have 24 atomic mass units, and the units for that is a U. I'm going to multiply that by 0.7899. Where did the 0.7899 come from? Well, that's the abundance of this thing, and 78.99% is actually 0.7899 in decimal form. And then I'm going to add to that the 25 atomic mass units. Actually, you know what? I think I'd rather use the bigger numbers, the more accurate numbers. So instead of writing at 24 units, I'm going to write 23.985 atomic mass unit, and that's represents that. And I'm going to multiply that by 0.7899. And I'm going to add to that the, let's see, 24.986. And I'm going to multiply that by 10%, so it's 0.1. And I'm going to keep all of my decimal places in order. And I'm going to add to that the 25.983, and I'm going to keep all of our atomic mass units, and the decimal that I multiplied by is 0.1101. So calculating all of that out, I end up with 24.30. And the question is, why did I cut it down to 4 significant figures, even though I reported 5 sig figs over here? 5 sig figs, 5 sig figs, 5 sig figs. Well, because the decimal only contained 4 sig figs over here. And when I multiply, I use the lowest number of significant figures. So my answer is 24.30. So if you look on magnesium, and I think I can pull that up on my periodic table over here. Let's see if I can find it. All right, let's see. Magnesium is 24.31 atomic mass units. So that's pretty close to what we got. And that's how they did it. They didn't actually go out and measure any magnesium that was exactly 24.30. That is just the average of all the different magnesiums you could find. If you were to randomly go off and pick up some magnesium, chances are the isotope that you would have in your hands is magnesium 24, because you have an 80%, almost 80% chance of picking that up, whereas you only have a 10% chance of picking magnesium 25 and a 11% chance of picking up magnesium 26. All right, I know that that was a lot, but essentially I wanted to make sure that you understood where the equation comes from, because my biggest pet peeve is that, you know, I just give you an equation and you use it and you don't really understand how it came to be.